Good day, dear students. I'm Mrs. Aline Leayatko, your science teacher. I hope everyone is feeling okay and in good spirits. Are you ready to take another activity for the third quarter? Good. Let's begin. The most essential learning competency number 14 is explain what happens when volcanoes erupt. Part of understanding the process of volcanic eruption is the substance that volcanoes release in this spectacular event, lava or magma. We call the substance lava when it has already been released by the volcano during an eruption. On the other hand, we call it magma when it is still under the Earth's surface. Whether it is lava or magma, it is composed of molten rocks. Rocks melted under high temperature and high pressure underneath the Earth's surface. Our topic for this session is factors that affect the viscosity of magma. But before we go into that, let us review some concepts we have learned from our previous lesson, which is types of volcano according to cone shape. First question, broad, slightly domed structure that resembles a warrior's defense tool. An example of this type is Mauna Loa volcano in Hawaii. And the answer is correct, shield. Next question. This type has a steep slope, wide crater, and is the most abundant of the three major volcanic types. An example is our very own Taal volcano here in Batangas. What do you think is the answer? Correct, cinder cones. Third question. Also known as stratovolcanoes, these are large, nearly perfect slope structures. Mayon volcano in Albay is an example of this type. Do you know the answer? Good job! It is composite. We can now describe or classify volcanoes according to cone shape, since all of us already know how to describe the three different types. Let's now go to the present topic. The objectives for this topic would be, let us read aloud 1, 2, blow. I can enumerate the factors that affect the viscosity of magma. I can perform mini-scale experiments and infer that the effect of magma viscosity to the rate of its flow and the effect of the amount of gas on magma viscosity. At this point, I would like you to get your study sheets so that you can follow as I go through the instructions. Please get your information sheet and the activity sheet for MELC 14. Let's go to view and think. At this point, we will watch a short video clip so that we will be able to define or describe what viscosity is in terms of how long it takes for a marble to travel through a liquid. So let's start the video. So it will only take a few seconds. So we will choose measuring viscosity in YouTube and then share the screen. So let us go back to our PowerPoint presentation. That was a short but interesting video clip on viscosity. So you have materials such as marble, the test liquids, as well as a graduated cylinder, which is actually the container for the liquids. So let's get to answer some questions. The resistance of a liquid to flow is known as blank. It can be described as how thick or thin a liquid is. The answer is viscosity. That's good. Next, a viscous liquid is a thick, thin liquid. Choose your answer from the words within the parentheses. A viscous liquid is thick, thin liquid. And you have thick. So in this case, a viscous liquid is a thick liquid. Kapag malapot ang isang likido, more viscous ito. Third question. The more viscous a liquid is, the faster, slower the marble travels through it. The more viscous a liquid is, the faster, slower the marble travels through it. Our answer is slower. So, the more viscous a liquid is, the slower the marble travels through it. Kapag malapot ang isang likido, mas mabagal ang pagtakbo ng holen doon sa likido. Now, if we are going to relate the different test liquids to magma, we could ask, is magma thick or thin? Instruct and act. Now you were encouraged to go over the information and activity sheets which were uploaded in our class GC. We will answer some questions, then proceed to the steps for task 2, viscosity raise, and to task 3, which is blow harder. Now allow me to define viscosity. It is the resistance of a liquid to flow. We can also describe viscosity as how thick or how thin a liquid is. In terms of magma, the viscosity of magma is affected by three factors: its temperature, the amount of silica present in magma, and the amount of gases present in magma. The viscosity of the magma also affects the flow rate of magma. Kapag pinag-uusapan natin yung flow rate, gaano ba kabagal o kabilis umagos ang magma? Now, first question. What are the three factors that can affect magma viscosity? Our answers are temperature, amount of silica, and amount of gases present in the magma. Second question. The higher the temperature of the magma, the less viscous it is. This shows the relationship between temperature and viscosity. So the answer is less. The higher the temperature of the magma, the less viscous it is. Kapag mas mataas ang temperatura, mas malabnaw ang magma. Third question. Magma will become viscous when there is a greater, lesser amount of silica in it. That is right. The answer is greater. When there is greater amount of silica in magma, the magma will become more viscous. Let's proceed to tasks 2 and 3. Task 2 will help us relate magma viscosity with that of the rate of flow. while task 3 will help us relate magma viscosity with the amount of gas present in it. Task 2, viscosity race. These are the objectives. I can determine the viscosity of select liquids. I can differentiate the rate of flow of the test liquids. I can define the relationship between magma viscosity and its rate of flow. Materials to be used. We will need a chopping board or tray, test liquids, pile of books or cartons to hold the chopping board steady, pencil and ruler to draw the starting and finish lines, and a timer. We can use our cell phones for the timer application. Now let's have the procedure or the steps. I have included in the procedure are some photographs when I was the one who performed the experiment before presenting them to you. So let's see. Prepare the test liquids as well as their containers. In this case, I used spoon so that I would have similar amounts of the liquid. You may use other containers such as plastic cups, small bowls, and other containers which you might have. What is important is that the amount are the same for all liquids and all trials. Now we prepare the test liquids. We have 4: water, cooking oil, syrup or honey, and ketchup. Now if we do not have syrup, we may use condensed milk. Now let's prepare the racetrack of the liquids. Now we have the chopping board or the tray, and then we will place a starting line on top and a finish line at the bottom. You can use either strings, thread, sinulid, similar to what I used in our chopping board. You can also trace it using a pencil. Now for the distance between the starting point and the finish line, you can decide what would be the distance between the two lines. Again, what is important is that in all of the trials and in all of the liquids, you are going to use the same distance throughout the experiment. Now, we will place the chopping board or the tray setup in a slanting position. Take a look at the photograph. And we need to keep the chopping board steady. Now, the position of the chopping board must be maintained throughout the experiments. We can now pour the liquids in their container, and we will make sure that we put the same amount for all liquids. Then we will be ready with our timer using the cell phone. Now we can hold now the container at the starting line. This is getting ready for the race. Pour the liquid just before the starting line. Start the timer once the liquid starts to cross the first line. Stop the timer once the liquid touches the finish line. So once the liquid touches the starting point, start the timer. Once the liquid touches the finish line, stop the timer. Now, in this case, you can pour test liquids one at a time. Remember to use the same amount of same amount of material for each liquid and same amount of liquid for each trial. You can also do the liquid race similar to the one in the photograph. In this case, you could use the lap button in your timer. These are other photographs of the viscosity rays. So the one on the right side would show us once almost all of the liquids have already touched the finish line. Now we will write the time reading in the viscosity rays table. We will do free trials for each test liquid and then calculate the average travel time. So how do we calculate the average travel time? Let's say, for example, we use the time readings for water. So you have free trials. You will add the first plus the second plus the third time reading. The total, then you will divide it by free. Why free? Because we have free trials for each liquid. We will also calculate the average time, the travel time for the syrup, the cooking oil, and the ketchup. Once we are done calculating the average travel time, we can now answer the guide questions. At the start of the experiment, you were asked to predict which among the liquids would be the fastest moving liquid, which of the liquids would be the slowest. So guide question number 1 asks us, is our prediction correct? Number 2, which liquid is the most viscous? Ano nga ibig sabihin pag most viscous? Pinakamalapot. So how do you know that that liquid is the most viscous? Number 3, which liquid is the least viscous? So in this case, the liquid na yung pinaka-malabnaw. Then number 4, compare how these liquids flow with how you think lava flows. So let's compare these test liquids with lava. Why do you think some lava travel faster than others? Now you will write your answers on intermediate paper. For those who are given hard copies of the activity sheets, you're going to write your answer on the activity sheet itself. Let's now go to task 3, blow harder. The objectives for this mini experiment are: I can describe how liquid moves when air is introduced to it. I can differentiate the movement of liquid as observed. I can define the relationship between magma viscosity and the amount of gases present in it. Materials to be used: syrup, clear drinking glass, and a drinking straw. Now, in this particular activity, if you do not have syrup, instead of using condensed milk as substitute, you will prepare your own syrup by mixing 1/2 cup of sugar with 1/2 cup of water. So this is equivalent to 1:1 by volume, sugar to water. Now, the first step, of course, is to prepare the materials. As I've mentioned earlier, you have your syrup, your drinking glass, and your drinking straw. You will mix, if you don't have syrup, you will mix or you will dissolve sugar in water. Now, these photographs, on the left side, you already have the mixed syrup, and on the right side, you have the use of a taller glass to prevent syrup splatter when you introduce air by blowing into the drinking straw. Now, what are we going to do? First, using the drinking straw, blow some air into the bottom of the liquid. Then observe the liquid's movement. Step 2, you are asked to blow again. But this time, you are going to blow harder into the bottom of the liquid. So, mas malakas ang ihip sa pangalawang beses. And you will also observe how the liquid moves this time. So you're going to compare your first blowing with your second blowing. You're going to compare the movement of the syrup as you do the blows. These two photographs show how the air was introduced into the syrup. After observing the movement of the liquid, you will now answer the guide questions. These guide questions are also given in the activity sheet. Number 1. Compare the movement of the liquid as the bubbles move to the surface of the syrup. You were asked to observe. This time you're going to write it down. Number 2. In this activity, you have observed the effect of the amount of air in the movement of the syrup. If the syrup represents magma, what do you think is the viscosity of magma in terms of the amount of gases present in it? You will write your answers on your intermediate paper or on the activity sheets themselves if you have a hard copy. At this point, what questions do you have about the instructions for tasks 2 and 3 of this week's topic? Any questions that you may have within this week may be sent through our class GC or via PM. Now let us summarize what we have learned. Viscosity is the resistance of a liquid to flow. How thick or how thin a liquid is. We can also define viscosity as such. There are 3 factors that can affect magma's viscosity: temperature, amount of silicon, and the amount of gases present in it. And of course, how magma flows depends on its viscosity. Let us now take note of how we can apply what we have recently learned. On the screen, you have 2 volcanoes, active volcanoes in the Philippines, Mayon and Taal. What do you think is the cone shape of Mayon? What about Taal? Now, in this case, we can actually relate what could be the cone shape of a volcano depending on its magma's viscosity. So in the second question you have there, infer the magma viscosity of Mayon volcano and of Taal volcano according to their cone shape. If, for example, the magma is less viscous, will it travel a short distance or a longer distance? If the magma is more viscous, what would be the rate of flow? Would it be fast moving or slow moving? Until the time the magma solidifies and becomes rocks, then you would know what type of cone would be formed for each volcano. Write your answers on your answer sheets. Last year, we have experienced a volcanic eruption through the courtesy of Taal volcano. Now, at that time, most of us, uh, were surprised, were caught by surprise when Taal erupted, when the magma moved within the volcano so fast until such time that it erupted. So most of us experienced being relocated to other shelters, and that was the first time we experienced a lockdown. Now recently, Feewoks has been in the news, stating that there is some kind of activity under Taal volcano for the past months. So people, especially Batangueños, cannot help but wonder when Taal might erupt again. However, according to Petra Nemkova, we cannot stop natural disasters, but we can arm ourselves with knowledge. The experience we had from last year's eruption more or less should have given us knowledge on how to prepare for such a disaster. We may not be able to prevent the disaster from happening, but we are able to prevent the hardship that we experienced during last year's eruption. For your assessment, you have here 6 questions, and you are asked to choose the correct answer from the items within the parentheses. I will upload the questions in our group chat. Please write your answers after those in the application questions. Gentle reminders. May I remind everyone that the submission of your output for this week's activity sheets will include the results and the photographs of your mini-scale experiments. You can send the pictures of the experiments of you actually doing the experiment through our GC or PM. When submitting online, please make sure that the photographs are clearly captured. It is a bit difficult to read your answers when the photographs are blurred. Thank you for listening. This has been Mrs. Yatko, your science teacher. These are our references and also for the pictures and the video. Volcanoes are actually majestic. They're beautiful. But when Mother Nature becomes angry, they could be frightening and dangerous. Take care, everyone, and stay safe.